Music. This video discusses the principle of controlling DC motors using a bridge circuit. The operation of the L298H integrated circuit is also discussed. The video shows the step-by-step creation of a management project. An H-bridge is an electronic or relay circuit that allows voltage to be applied to a load in different directions. This changes the direction of the current and the direction of rotation of the motor. When output Q1 is turned on, relay K1 is activated. With the help of the contacts of which the motor is turned on in the positive direction, the motor rotates in the plus direction. The direction of rotation is arbitrary. When output Q2 is turned on, relay K2 is activated, with the help of whose contacts the negative direction of rotation is switched on. The motor rotates in the minus direction. What happens if both relays fire at the same time? The result will be a short circuit in the motor power supply circuit. The first bridge circuit can also be implemented on the basis of normally open contacts of the controller output relay unit. Let's create a control project based on a DC motor. Automated gates open when you press button S1. By pressing the second button, the gate begins to close. In the final retracted position, the gate stops. We use the simplest control method. A bridge circuit, 2 control buttons. 2 relay outputs will turn on simultaneously. Moreover, outputs Q1 and Q3 determine the direction of rotation in one direction. For example, in the plus direction, and outputs Q2 and Q4 cause the motor to rotate in the other direction. The motor can rotate in one direction, doing, for example, some work to open, stop and rotate in the other direction, that is, it reverses. Let's change our program in such a way that we will have a memory element. Button presses will be short-term. Let's insert the RS trigger function. The direction of rotation, plus, starts with pressing button I1. Rotation in the other direction begins by pressing button I2. At the same time, our buttons are not fixed. The motor will stop when pressing button I3. In this case, this button is normally closed, without latching. Therefore, it will be necessary to install an inversion. So, let's check how the program works. Briefly pressing button I1 turns on the motor with the direction of rotation, plus. We must stop. By briefly pressing button I2, the motor begins to rotate in the minus direction until we press button I3. The danger is that you can press buttons I1 and I2 at the same time. Thus, a short circuit will occur in the electrical circuit. Turn on the momentary button I1. Now switching off is possible only with the stop, I3 button. The limit switch, which is triggered at the end of the gate closing, does not give a signal. You have to press the stop, I3 button. We close the gate closes until we press stop. So, let's develop our program in such a way that in extreme positions the motor turns off automatically. There are 2 signals to turn off. This is a signal from the stop button or a signal from the limit switch. The limit switch for movement is I4. The draw-out limit switch is I5. Don't forget to set the inversion. Since the contact is normally closed I3. However, the disadvantage of this scheme is that the movement can be immediately reversed, which can lead to a short circuit. The project can be automated in such a way that the gate will begin to retract automatically after a specified time after it is opened. The opening will be determined by limit switch I5. We use the on-delay timer. Let's insert it into the program. Let's erase button I2. Since the gate will move automatically based on the timer signal. The input signal will be limit switch I5. The delay time will be 4 seconds. The gates are automated in such a way that after opening the gates, after a time delay of 4 seconds, they will begin to close automatically. Let's look at the operating principle of the L298 integrated circuit, which can be used to control DC motors. You need to understand that the power of this chip is limited. The principle of operation is based on the fact that this microcircuit contains 4 amplifiers. In order for the motor to start rotating, it is necessary to create a potential difference at the input. For example, apply a logical 1 to in 1, and apply a logical 0 to in 2. If the same signals are supplied, that is, logical zeros or logical ones, the motor will not rotate. If you create a potential difference between the first and second inputs, then a potential difference of 24 volts is also created at the output, and the motor rotates in a certain direction. If output Q2 is activated, then accordingly in 2 is a logical 1. And in 1 is a logical 0. Accordingly, the motor rotates in a different direction. So the driver is connected. Here is a voltage divider that is connected to the output of the logo Siemens for 2 outputs Q1 and Q2. If a potential difference occurs between the inputs in 1 and in 2, then a potential difference of 24 volts also occurs at the output of the integrated circuit and the motor begins to rotate. In this case, the motor rotates the shaft through a gearbox. If the signals in 1 and in 2 are absent or both are turned on, then no potential difference occurs and the motor does not rotate. If you turn on both inputs at the same time, then the motor stops. There is no potential difference.